This is Professor Ricardo Jimenez, and today we're going to see details about how to design and improve the coffee vending machine controller using a big micro. And even when we will not see the full code here, we will see parts of how to improve this design that was assigned to all of you in this course. So, and in this vending machine that was assigned to all of you, we have three different types of coins: the nickels, dimes, and quarters right here. So, and notice that they are in RB0, RB1, and RB2. So one method is to ask 3 times if RB0 is equal to 1, then go to nickel. If RB1 is equal to 1, then go to dime. Or if RB2 is equal to 1, then go to quarter. So that way you can do the additions to display the amount of money. But in this case, of course, when you add them, you will display here the amount in such a way that the user can see how much money he has deposited. Okay, and for doing that, we're gonna see these instructions. So, and right here you can see that we have the instructions, and we will be using the branch instruction. So that branch instruction, let me take it from here, from the handbook. The branch instruction is original located on page 57, so because later we will see this one on page 155. So, and we are here. And here it is. Okay, the branch instruction has an index, or we can call it pointer, and depending on this variable, the value of this variable, it'll point to the different labels we have here. And this will be labeled 0. If the index here is 0, it'll point here, or it'll jump to this location. If it is 1, it'll jump to that location. So and this is one way to do it. Another one is branch L, or another one is on go to. Okay, so in this, once we have seen this instruction how it works, for example, right here you have branch B4. So if B4 is 0, jump to dog. If B4 is 1, jump to cat. If B4 is 2, okay, jump or go to location fish. Okay, so how are we going to use that in our code for this vending machine? Is this way. So first you read port B, okay, and let me put it in blue. So you read port B and you do an isolation using a mask, and the end mask, this mask, in such a way that you are masking these bits that you don't want. That is, and the ones that you really need is RB0, RB1, and RB2, because it's where you are reading the 3 types of coins. And RB3 through RB7 are isolated. They are used for other purposes in the vending machine. So in this, with these 3 sensors, you can only detect 1 coin at a time. So you have binary code here 1. Notice that this digit represents RB0, this one RB1, and this one RB2. So you have this code, number 1 is equal to nickel. You have this code, number 2 in binary, that's equal to dime. And you have the third sensor, that one, that's equal to quarter. And what number is this in binary? Is number 4. So you have number 1, number 2, and number 4, the ones that we really need. Okay, and I'm gonna put them in red. So if there is no coin, it'll jump to the same label to coins. That way it'll keep reading or waiting for reading the port, waiting for a new coin, to be detected. So if you have here, let me click this. If you have this number, so 1, and that means, let me get it in this color. Okay, you have number 1, that's a nickel, and that's why it'll jump to nickel. If you have location number 2 for this one, the index will take this location, dime. And if you have number 4, so number 3 is not used, you have number 4, it'll be here. Okay, it'll jump to quarter. Why I'm not using 3? Because I can't have this one and this one, so 1 plus 2. I can't have a nickel and a dime at the same time, so n will never be equal to 3. If that happens, that means the sensors are bad and I have a wrong number, so it has to go to repair. That's a label where you can send a message on the display indicating that the sensors need to be repaired. If you have number 4, that's okay, it'll jump to label quarter. Label quarter is here, label dime is here, and label nickel is there. And you have numbers 5, 6, or 7, it'll go to repair because that's impossible. We can have combinations of 2 more coins or 3 coins, as it will be the case of 7. So this is why I'm sending this to repair. And of course, right here, you can place your label repair, okay, where you send messages to the display, like let me put it just as an example: LCD out, FE, so clear the display, comma 1. Now we're ready to send a message, like check sensors, or it could be the message, so repair sensors. Okay, so, and that's how the user, if you see that means it has to be repaired. It'll be no accepting coins. But for how long you want to have that message? Let's say pause for 2 seconds, and then you send another message. Okay, but every time you send a message, you have to make a pause. That way you give time for the user to read it. Okay, so this is one way to solve the issue of detecting all these stages, all these different types of coins, the 3 types of coins. So if there's no coin, the number will be 0. So there's no coin, it jumps to this label, so it goes back to here. Okay, that way you know that you want to read it again. You want to do a loop, continuous loop. Okay, so and this is the index and of the pointer that is pointing depending on how it is reading, or how or which coin was detected. Okay, so this is one solution for, instead of using a repetitive if then else for every single case. And there are other formats like the on, go, sub, and other ones, but at this moment in this short video I just wanted to explain the branch instruction to detect these 3 types of coins. Okay, notice that I place the sensors in these locations: RB0, RB1, RB2. There might be in other locations depending on how your assignment was given, but you feel free. This is of course I'm here just placing the inputs and outputs, but you can place them in other ports. Just for the sensors, I just want to show you that when you have this type of this type of microcontrollers. Here, this microcontroller is driving a numerical LCD directly. Every color is for every digit, and right here you select the options. These cables are driving the digital in the middle, the digit on the right side. And this is an optical sensor, so this one can be used to detect coins. That one type of coin, or different types. There are methods to detect different types of coins with a single sensor. You see, now it is focused right there. So this is an infrared sensor. I still need to connect it to the micro so that when we detect here quarters, it can be adding by like 25, 50, 75 until it reaches the amount that you are programming. So this is how this project will look. And of course, we can place here a isolated relay or opto relay. This relay is opto isolated by that infrared light. And with this relay, we can control the coffee machine, the hot coffee or hot water, okay? So that's the way to design this type of projects. Okay, but if you want to use alphanumerical display, this will be the case. The same micro is driving with 6 bits, is driving the LCD, so you can see the messages right there. Okay, in another short videos, I will explain more details about these types of designs on how to improve them. Thank you.